Welcome to your examples. On to our first one. So in a couple of questions you'll get asked whether something is an expression or an equation. Just a quick little reminder, if it is an expression, there is no equal sign. So there's no equal sign. If it is an equation, we will actually have an equal sign. So let's have a look at our statement here. I've got 3x plus 7 equals 13. I've got that lovely equal sign, which means it is an equation. So it's a mathematical statement saying that the left-hand side equals the right-hand side, therefore it must be an equation. Moving on to the next one. B. Sometimes you'll actually get questions where it asks you if the left-hand side equals the right-hand side by saying, is this equal to this? Is it true or is it false? So the first thing you're going to do with these types of questions is you are going to break them down and have your left-hand side, break that down and answer, put as much as you can together, and then do the same for your right-hand side. So for my left-hand side here, I have 2 plus 3, which gives me my answer of 5. And I have my right-hand side, which is 9 minus 4, which equals 5. If my left-hand side equals my right-hand side, the statement is true. Another way that we can actually write that would actually be LHS, so my left-hand side equals my right-hand side, therefore the statement is true. And again, it's good to use some of that notation, and that's what we write if it is true. Next one, sometimes you can be asked to actually substitute something in. So, just like we had before, we're finding if it's true or false, but we've got a particular case. So instead of being given just numbers, we've actually got a pronumeral in here. So I've got my statement here of x equals 5, and I'm substituting it into this equation here. Okay, and the reason I know that it's an equation is because it has that equal sign. So it's not just an expression. So we're adding just an extra little layer. So with this particular one, I substitute in my 5 where I have that x. That would be my first step. So 4x minus 8, and again, I put it in where the 5 is, and I write out all my steps. If you are not writing it out, you are more likely to make a mistake. So write it out, okay? So we start off with our left-hand side. So our left-hand side is then 20 minus 8. So our left-hand side is 12, or our left-hand side equals 12. So I could write that here. My left-hand side equals 12. Having a look at my equation, my right-hand side, and again, let's put those labels in. My apologies. We've got our left-hand side, and we've got our right-hand side. Our right-hand side is 10. Not on this planet. Hope not. 10 does not actually equal 12. Or sorry, other way around. 12 does not actually equal 10. So if our right-hand side and our left-hand side do not equal each other, so left-hand side is not equal, so we use this symbol here, to our right-hand side, the statement is false. So I could write it like this, as my left-hand side does not equal my right-hand side, therefore it is false. Next one, I'm going back to a little bit more of how we write certain expressions, but now we're doing it as an equation. So we need to look for ways that we can actually look at words to figure out whether we've got maybe a plus, maybe we've got a minus, multiply, or a division. And also for this one, equals. That word equals, we have a few different words for that. So the difference between 6 and y. So difference, this word difference here, actually means the answer from subtracting two numbers. So it's the difference between these two numbers. So 6 minus y. So the difference between 6 and y. So 6 minus y gives me my answer of 6, and the difference between 6 and y. This word is really important. This word is actually means equals. And we've got our last number there is 4. So again, you're looking for where you can actually bring in your operations onto our worked examples.